I'll get you there.
Sudoku Degenerates, welcome. This is my Thursday puzzle stream. Oh, hey, Dorlier. I should have time for yours today. Huh? How did this... Huh? Manage tab group. What? No. Wait. Wait. Okay. That's weird. Alright. Oh, hey, Chinstrap. And AQ, welcome. I believe AQ's is second, Chinstrap's is fourth. I should have time for everything, especially because I only need to do one of these three puzzles left. Alright, this is the 9x9 version of A Map to Distant Lands by Bookworm. Alright. Oh, hey, Jojo. And Phil the Hat. Welcome. So, it is, it's doppelganger rules. Every row, column, and box contains the digit 0 always, as well as 8 out of the 9 digits from 1 to 9. So it's missing one digit that is not 0. That digit goes here. The digit missing from this row goes here, from this row goes here, and the digit missing from this column goes here, digit missing from this column goes here. Yes, I can imagine that would be hard. And the digit missing from this box goes here, digit missing from this box goes here, this box goes here, and these must also all be 9 different digits. These must also be 9 different digits, and so must these. Coordinate. Oh, and for each 0 in the grid, the digits missing in its row, column, and box must be 3 different digits. So if this is 0, then these 3 digits must all be different. The cell, okay. Digits on an arrow spell out the coordinates in the main grid for the digit that is their sum. The row number is written on the start of the arrow. The column number is written on the arrow tip. If, for example, an arrow looks like this, 1, 4, then there must be a 5 in row 1, column 4. Same goes if this is 1 and this is 4. Or if this is 1 and this is 4. Digits may repeat on an arrow if allowed by other rules, and 0 cannot appear on an arrow. And these must be odd. That's all we get. Okay, so none of these can be 0. Now, the one thing we learned, I first learned this in Glowworms, is these 3 digits must be the same as these 3 digits, because this is 3 lots of the digits 0 to 9, and those 3 boxes are 3 lots of 0 to 9 minus 3 missing digits, 3 distinct digits, and those digits, therefore, must go here. So these are the same as these, but these must go in different... Well, okay. How to put this is, if I make these red, green, and blue, and these orange, yellow, and pink, I can color these like this, and these like this. Now this also means that pink must contain 1 digit from red, 1 from green, and 1 from blue. This also means, okay, I can never put 9 on an arrow. So 9 must be down here, which means it's blue. Okay, so this is 9. Specifically, 9 is in one of these. Alright, so 9 does not appear on this row. Okay. 8 is either up here or here. So it must always go with a 1. So either row 8, column 1 is 9, or row 1, column 8 is 9. Because 8 either goes up here or it goes down here, which means it goes here. So 8 is always on at least one arrow. It can't be, well, it can't be here specifically, or here. So each of these contain an 8. So there is... What do I do with... Oh. Oh, and there's also all the arrows must correspond to different coordinates. Oh, does that mean... if this is a 1-8, then there's also... Would that make this 1-8-9? Okay, I'm guessing either this is 1-8-9 or these are both 9s. Well, no, that's only true if 8 is down here. What if it's up here? Like, could it be here and... and in one of these? I think that works. Or here. Here and... here. Can I do something similar with 7? If there's an 8-1 here... could put 7 with a 2. Of course, that would greatly reduce the number of 9s here, but... well, I know every digit except 9 appears at least once on an arrow. So I know either one of these is an 8 or one of these is a 9. Which would prevent... I guess if this is 8, these could both be 8. If this is 8, these could both be 8. So, like, regardless of where 8 goes, it can be on one... can be on only one arrow. That might be more of a problem if I can also only put 7 on one arrow. Now, 8 can't go on any of these arrows and also appear on any of these arrows, right? Because it can only ever go with a 1, and I can't put 2 digits in the same group, in the same color grouping on both of these. So if any number that goes on more than one arrow must either, well, no, it could go with different digits. Like a 7 could go with a 1 and a 2. Now, can I prove that, like... okay, if this is 9, then this is 9, and this is 9. That would mean one of these is 8, and one of these is 8. Oh, good point. Wherever 9 goes in here. Right, if this is 9, then these are the same. If this is 9, then these are the same. Same digits, which means they must be the same. Right. So if this is 9, then these are the same. And it couldn't be... Okay, if this is 9, then these cannot be a 1-8 pair, because then both of these would have to be 9, and if this is 9, this can't be 9. And if there is... Right. Okay, if this is 9... Now, if this isn't 9, is there some way that these could be not the same? Oh, well, if this isn't 9, one of these goes on here. The other two digits both go on here. So could this be a 189 triple? That feels a little... well, no. If this... If this is 9... Could these be a 1-8 pair? This being 8, this being 1. So this would have to be the 1 and the 8. Then these are both 9. What? What is wrong with that? Is something wrong with that? Now 7 can't go there. Oh, now 7... Oh yeah, in this case 8 goes here. And there's a 1 up here, but 1 being on an arrow is not terribly surprising. Wait, no, one goes up here. I guess 7 has to go here. So this is 7, 2. Oh, that breaks. Okay, it breaks because now 7 has to go here. Which forces it on here. Okay. And I think that works no matter what... Yeah, because if we make this a 9 and have a 1-8 pair above it... then 7 is always going to go down here, which forces it on here. Okay, okay, so 8 does not go above 9. Now, question becomes, can it... If 7 goes on more than one arrow, it must go with a 1 on at least one of them. Yeah, it could, but in this case, we've already ruled 1 out of here, because 1 is up here. Like, if this was 9, 8, 1, then 1 is up here, so 7, which goes on here, must go on here, but the 1 is up in red. So it couldn't do that. So we know that... So we know that 9 does not go with a 1-8 pair above it here. So none of these are a 1-8-9 pair. In fact, whichever of these, whichever of orange, yellow, or pink has the 9, it doesn't have an 8. Oh, well, okay. Let me explain it this way. Where does 7 go? Because if this is... These are 9s. Because these are 9s. In fact, this is 8-1. And now, wherever 7 goes in this box, if it has to if it goes on any of these arrows, it has to go with a 2, which makes one of these 9s, which they can't be. And I think that's true no matter which of these 3 columns we put the 189 triple in. So 7 cannot go on these arrows, but that forces it down here, which forces it onto here, which breaks because 1 is up here now. That's a bit convoluted, but it does seem to be the sort of deduction we're dealing with here. Nine on blue pink. Seven up here. Well, but then these must be different. And like... yeah, so one of these is a 9. Yeah, it's fine. I mean, this would be fine as long as we don't put 8 here. It only breaks if we put 8. It breaks if we put 8 here. Yep, exactly. The 1-8 pairs give us both 9s here if we put 8 above 9. It is tricky to explain, but this puzzle be like that. Hey, Screaming Ice Cube, welcome. Yes, pretty colors. Fiendish logic, but pretty colors. So we've proven that 8 cannot go above 9 in the box list. Now that raises the question, what if this is a 1-8 pair? There must be an 8-9 here. Oh, 7-2 is still a problem? Okay, if this is 1-8 and we assume that, oh, let's pretend we know it goes like that. Okay, and now if we put an 8, I think we can still put a 9 here with a 7-2 pair somewhere else. Or is there some reason why that doesn't work? Obviously, we can't put 7 here or here now. Okay, let's say we put it here. Like, 7, 2, 9. Oh, well, okay. Oh! 9 becomes an issue there. Look, because row 7 can't have a 9. Okay. Oh, but wait, does it work if we do it this way? 8, 1, 9? Because I think we can then put 2, 7, 9. Oh dear. Okay, so this would be the 9 in that case. So this is 9. These are 1-8 pairs. So, orange has a 2 and a 7, along with 1 or 8. Red has 2. Green has 7, which must go there specifically. Not seeing an immediate breakage. Maybe this is actually correct? The issue is, I think I can still put 1, 7 here and have an 8 here or here. Oh, wait. Is this correct? No. Okay, but I sort of chose these at random anyway, so... Doesn't mean it's not... Okay, what other deductions can I actually get? I mean... I know that there's no 0 or 9 on any of these arrows. Now, I think if I put 8, 1 on 2 arrows, then 1 cannot go on any other arrows, right? Oh, no. I could put it, like, here and here, but still have 1 with something else, like here or here. Is there some global, like... Oh, hey, Isaiah. Well, I can't, I know that I can't, wherever I put 9 in blue, I can't put 8 above it. Like, if I put 9 here, then neither of these can be 8. If I put 9 here, then neither of these can be 8. And if I put 9 here, then neither of these can be 8. I also know that neither of these can be 8 anyway, because each of these is on 2 arrows, and I can't put 8 on 2 arrows in the same box. I know that it goes on at least 1 arrow with a 1, and therefore at least one of these is 9. I haven't made much progress further than that. What deduction did you make? I mean, I already know that, like, blue must go in 3 different trios on the bottom row and vice versa. Like, I can't put... Yeah, that's this color, right? But... I mean, I know every digit goes on at least 1 arrow, except 9. The arrow for the bottom 3 boxes, you mean this? The doppelganger digits for a box. What are... Sorry, what do you mean by doppelganger digits for a box? Do you mean the missing digit, or like something to do with where the 0 goes? Oh, these? Oh. 8-1. Okay, so there's always a 7-2 pair. And it's here. Okay, so there's only one arrow. Okay, so this is 9. Right, because every digit except 9 goes on, because the other two here are on an arrow. So every digit goes on a buck on a distinct arrow, on at least one distinct arrow. Now I know that these are not a 1-8 pair. Could they be a 7-2 pair? There's also the fact that these are the same as these. So, oh, but I can't make these a 7-2 pair either. Because then I'd need to put it on 2 arrows, which would make both of these 9s, which doesn't work. Okay, so there's no 8 or 7 above here. Now, can I put... Could I make this the 7-2 and this the 8-1? That would pretty much have to make this 8, right? Oh, and this 8. So there's a 1 here, probably a 1 here too. Oh, hey, Bookworm! This, I was just doing a little bifurcation there, but here, this I have actually deduced. Well, I know at least one of these does have to be 7 or 8, because I can't put both 7 and 8 here. So, like, either... So basically, there is a 7 here with a 2 here, and there is an 8 in one of these with a 1 here. But I don't know for sure that this is one of them. If this is 8-1, then these are both 8s. And I know there's no 9 in this box, but that's for this row. How did I... Oh, yes, I used this to rule this out from being a 9. So I know one of these is 1. Which is basically just another way of saying one of these is 1. I've been there. One of these is 8. Now, if this is 8, then those are 8s. Does something go wrong if that... Okay, well then this is 1. So there's a 1 in here and a 1 here. If this is 2, 7, wait, if this is 2, 7, then this is 8, 1. Then these are 8s. Here and here. Now this 2, 7 though, that could still go 1, 7 in either order to put an 8 here or here. Oh, it would have to be here. If this is 7, so it would have to be here. Oh, that breaks. Okay. Right, okay, so this can't be 2, 7. Or could it be if it goes here? Yeah, I just realized I was assuming... Yeah, it could be 1, 2. So this would have to be 2, this would have to be 7. So one of these is 3, so that's not 3. Oh, but this would have to be 7. Oh, but wait. I can't put 1, 2 on the same arrow. Oh, wait. 3, 6, and 4, 5. Yeah, 9 here and a 9 here. Oh, it would have to be there. Okay, so there's a 5 in here. to 4 in here. That all looks like it works. Okay, I need some other way to narrow this down. What was the nudge you got, Isaiah? Where is... Oh. What about yellow? 3, 4, 5, 6. Right, and this must be yellow red, and this must be yellow green. Okay, so I cannot put... Right, these cannot be... These are the same thing. So these point to... Oh. Well, wait, couldn't these be a 3-6 pair? I don't think there's anything wrong with these both being 9. Then this could be the 4-5. Or is there some other reason why that doesn't work? Well, let me look again. So I guess in that case, this would have to be... Okay, this would have to... Oh, but each of these is also... Okay, so that doesn't work. Okay, so this is not 2-7. Because then both of these would have to... Okay. Right, it's both of these that have to go both ways if this is 2-7. What about... Did I miss something easier, or... Look again at this. So there will still be a 1 on here, which means this still has to be 7. So there's a 2 on here with the other of these. Specifically 2 with this. Oh, 7. Oh. Well, this becomes 2, and this becomes this. Not seeing any obvious reason why that breaks. Not true. Alright. What else can I... If there's a 4 on here, it must go with a 3. Oh. Right, there's always a 3 on here. And it's either this pair, either these are both 7s, these are both 8s, or these are both 9s. Now, what... if these are both 9s, that's... Oh, the 9s, are, I know all these 9s, and there's a 3 on here. So either these are both 7s, these are both 8s, or these are both 9s. One of those 3 things is true. Now, if it's that these are both 9s... then I think one of these 2 also has to be a 9. Because it's going to go somewhere... Oh, there's also... But wait, if this is 3, 4... Don't I have to have at least one arrow with only digits higher than 4 on it? That doesn't work. Wait, is that actually forced? Like, say this is 3, 4. Right, because no matter where I put the... I... Actually, what? This might... Is this forced to be 3, 6 because otherwise I have to force like 4, 6 onto an arrow? That is tough to see, but I think... Wait, if this is 8, 1, doesn't that mean I could put a 1? Oh no, not in here. Right, right, yeah, okay, right, yes, okay, yes, okay. And since this is not the box that is missing 9, that forces 9 up here. Oh. So there's gonna be a 4, 5 pair on one of these arrows, I'm betting. There's a 9 down here. Why did I roll 7 out of here? Now, there's a virtual arrow here. Right, and that's going to use, yeah, that's going to force the 4, 5 arrow. Because these two are the same as these two. Wait, I think this can only be 2 or 4, right? And this can only be 5, 7. Hey, Ambrose. Forces the 8, 1. Oh, okay. Okay, so if this is 8 and this is 1. Oh, wait. If this is 8, 1, this... How does it... Wait, how does it force the 8, 1? Not seeing... X similar to 9. Okay, so... If this is 8, 1... One of these is 8. Wait. This is 8, 1. 8 in blue makes 2 arrows with the same digits. What? Can't I just make one of these 8 and not have that? Oh, maybe it's 8 down here that causes the trouble. No, if this is 8, then these are 8, but I think that's still fine. Or is there something else here? Okay, what is... Oh. Right, and whichever of these is 8, right, and I can't have 2 2 7s or 2 4 5s, right, okay. Took me a moment, but eventually I got it. Alright, okay. Okay, so this is 7. But 1 and 7 are both in green, so I could still have... Oh, no, because these are... Right, okay, so 7 does go up here. Oh, wait, this has to be the 2. Because this and this are the same. Can I do that? Okay. So these 2 are also... Oh, wait. These can't both be 5s. So these are both 8s. Okay. Now we have... Ooh. So one of these is 4. And either one of these is 5 or one of these is 6. Now if it's here... that can't be 6, so that would have to be 6, which makes that 5, 1. Now either one of these is 6, and it can't be this one because of this, or one of these is 7, which works fine, according to this arrow. Okay, I should start thinking about zeros. Oh, in fact, none of these can be zeros. Alright. And none of these can be zeros. None of those are zeros. Okay, so there's a zero here. Oh. No zeros here. Alright. Oh. Oh. 8 in this box. Okay, so that does a lot, actually. I now know this is a 0-9 pair. Am I missing any other obvious? There's an 8 down here. That is 2. Oh, wait, no. Oh, right, there's no 8 in here anyway. Wait. 3. Well, oh, this is 1. Because one of these is 0, so this can't be. Oh, hey, juggler! Okay, so 1, 3, that's 4. That is... Okay, so that is not 4. Oh, in fact, wait. Oh, this can't be 5 either, because this would have to be 1. So this is 1. So either this is 5 or this is 6. Wait, this can't be 4, right? Right, because this can't be 6, and this can't be 9. So this is not 4. If this is 5, and this is 7, which works fine. Alright, now that I know this... This is 6, this is 7. Either this is 6 or one of these is 7. Alright, let's see. I also can't put 7 on here. Or wait. No, because this can't be 8, right? Okay. This 7 also rules it out of here. Okay. Yeah, I think I said last time when I did the 4x4 and 6x6, this reminds me of Glowworms by Math Pesto, which is one of the best puzzles I've ever solved. Yeah, scanning is a bit weird. I know anything about what this can be? Six. If this is 2, this is 5. So this would be 7, this would be 5. If this is 6. Oh, wait. This can't be 5 because this would have to be a 4-2 pair. These are both 6. Okay, so this is 4. Okay, and we have our first 0. Ah. So one of these is a 7. Do I know which one? I also know there's a 7 here. Oh, but this... Oh, that makes this 4. And this 5. There is a 4 in this box, and it can only go there. Two in this box can only go there. 2 in this box can only go up here. back 7. Oh, right. Yeah, now that I know this, yeah. Also, hey, Drunk Chess. Right, so this now... yes. Okay, so we got a couple of 0-9 pairs. In fact, we have an X-Wing on 0s and 9s. Which gets us... okay. Oops. I can get rid of this coloring now because I've got all the 0s but this X-Wing. Whichever of these is a 0, it's gonna resolve this or be resolved by this. Oh, this can't be 3. This can only be from 1, 2, 4, 5. Oh. This can't be 4, because... Oh no. This could still be 5. Oh no, this could be 4. This can't be 6. Wait, if this is 1, this is not 2. No, if this is 1, this is 2, or this is 4. What if this is 2? This could be 3. Oh. Fair point. Able to be indexed. I know... It's basically any of these... Okay, This is not 4. If this is 4... Can't this still be a 2? That would resolve this. Oh, no, this. That would be indexing this. Right, this isn't 4. Right. Okay. I was miss... Should I think I'll uncheck the ones that are already indexed. Or maybe I should mark those a different color. Well, 1, 3 is 4. This is not indexable. If this is 4, this is 1. If this is 5, this is 2. I get both of these. Okay. If this is 2, this can't be 1, but it could still be 6? No, 6, 2, that's already... Okay, this can never be 2. This is 4, this is 1. If this is 5, this is 2. And if this is 1... this could be either 2 or 6 in that case. Okay. Okay, I should also think about these. Oh, technically these can be indexed. Except no, they can't, because those would necessarily sum to 9. Oh, any index cell in this diagonal sums to exactly 8. Any index cell along here sums to 7. These sum to 6. Oh, so these can't be indexed. This can't be indexed, neither can this, because it would sum to 8. Oh, and this can't be 8. Okay, so I could index up to 2 7s in here, 6 here, a 5 in either of these. Oh, can't index another 4 here. Okay. So these sum to 3, 5, 6, or 7. I know there's at least 1 7 and could possibly be 2. Oh, this can't be 5. Where does... Oh. Oh no, this is... And I know these can't both be indexed, because one of them's a 4. Wait, I've got 4 arrows left to resolve. 1, 2, 3... and only 6 places to put them. If this is... oh, right, yeah. Yeah, this can't be 6. Oh, in fact, there's nothing left indexable in column 6. There's nothing indexable in the first 3 columns that's in row 1. Ooh. Well, I know this is not... these aren't 6. But the trouble is, since these are in different boxes, I can't necessarily rule these out. Oh, except I can rule this out, because this would be 2. Oh, and this would be 4. Yeah, I think I could have a 3-3 here. Okay, so this, I can't ungreen this, but I can remove 1 from here. Oh, no, 6 doesn't work here because this can't be 1. I think row 8, column 6 is only one option. Right, if it's 2, that's 1. If it's 4, that's 3. Repeats on arrows, 3-3. It'd be 6, but no 6 in row 3. Ah, right. Okay, so so that doesn't work here. Okay, so none of these can be indexed. Okay, so I wasn't wrong to rule those out. No, okay. This could be 2, 1, 3. Oh. This cannot go here, but... Oh, it could go here if this is different from this. So, like, if this is 3, this is 2 or 4. It's 2, that's 5, 2. So that would be 7. Oh, 7 and row 4. True. Am I missing anything else obvious? No, we got the 6 out of here. 4 out of here. Right. Okay. this is 6, 1, this is 7, so this is 4. Oh. But then... Wait. I've got 4 arrows I need to resolve, but they're in 3 boxes, so there has to be some repeats. Now, if either of these is 6, if either of these is 6, it goes with a 1. That's a 7 there, so that's the only one in this box. So the remaining 3 have to be spread in these 2 boxes. So what is... What is... Can I get another nudge? This is... Okay, if this is... If this is 4... Oh, this can't be 4. This is either 2, in which case this is 1. Oh, this is always 1. Oh, and no arrow can end in a 3 now. Oh, this can't be 2. Because this would have to be either 2 or 5. This would have to be 5. And that breaks this. This is 3. So this is 2 or 4. So either this is 5 or this is 7. Missing an obvious reason why one of these breaks on this arrow, or Because AQ said this only has one option. I don't see why. There's two that are... well... If there's... Okay, going back to this, if this is... Three in this box can only go here. In this box, it can only go here. Oh. Right, it's up here, which means that is not... Okay. If it's 2, this is 1 or 5. If it's 6, this is 1. Okay, so this is not 4. Now... Oh. If this is 6... This is 7, so this isn't 7, so I can only have 1, 2, 5 arrow. So this would break. Okay, so this is 2. So this is 2, this is 5. If this is 6, this is 1. Oh, wait. If this is 2, this is 5, 2. I should also, where is, is that correct? Okay. If this is 2, this is 5. Okay, so one of these is 7. This is 2, 5, 5, 2, so one of these is 7. Wait, if this is 6, 1, this is... Oh, so this is always 7. And I know it's indexed by one of these two arrows. So this is number 4. This is 2. Oh, hey, Ratfangs. Ah. So that's not 6-1, that's 2-5. Okay, and now at long last, it should just be Sudoku. Six, 7. That's not 1. Okay. Oh. So this is 6, 7. 1, 6. Oh, 1, 6 pair. That's 7 in this box. What's left in this row? 1, 2, and 6. Well, that's not 1. Oh, that's 2, 6. Okay, 1 in this row. Alright, and this contains... Oh, this is 6. 4, 5. Resolved by that. Oh, right, and this, this is 9, this is 0. Because of the, number, okay. 3, 5, and 6. Well, that's 6. That's 5, that's 3. That's 2. Oh, 3. Four and 8. Do I know? Oh, I don't know which way around those go. At least not yet. Okay. 1, 4, 5, 7. That's 1. That's 7. Wait, no, not 1, 4, 5, 7. 1, 4, 5, 6. This is 1, 6. 4, 5. 4, 6. 4, 6. Okay. Wait. Oh, 5. 5 in this row. 2, 6, 7 left in this box. Oh, 6. Okay, so 1, 2, 7. That's not 1 or 2. That is 7. Seven. Yes, column 4 will have a 4, and it goes there. What's left in this box now? 1, 2, and... Oh, well, 1 goes there. 2 goes there, and what's left is... Oh, 3. This is a 1, 2, 3 triple. Can't be 1, that can't be 2, that can't be 3. Five, 6, and 8. That's 5. 6, 8 paired there. Hopefully that will be resolved by 1, 6, and 7. Oh, that's not 1 or 7. That is 6, 8, 6. That makes that 8. That's 1 or 7. I don't think I used either of these dots all that much. Huh. Well, maybe I used it earlier to... 3. Okay, that resolves that. Two and 6. 4, 7, and 8. That's 4, 8. That's 7, 8. That could still be any. But this 4, 8 pair here, I think makes this a naked single. It's a 5. Oh, and I could also look across here. 6, 7 resolved. Aha! Oh, yeah, it only took me 2 hours. Easy peasy. Alright, I need to refill my water. Alright, when I get back, I will... Oh, maybe I'll run a quick ad break here to disable pre-roll ads for a bit. Alright, be right back. Alright, we're back with Purple Hat Cheetah Print. Inspired by Dubious Mobius's Entropical Paradise. I don't think I've tried that one. Okay, so it's yin yang. Normal Sudoku rules apply, so every row, column, and box. Alright, I'll try that another time. Okay, every row, column, and box, gotta put the digits 1 to 9 once each. Divide the grid into 2 orthogonally connected regions such that no 2x2 area is completely contained in a region. Ah, that is the most concise way of describing yin-yang. That is fair, Screaming Ice Cube. All cells in one region will have a value of 2D, where D is the digit on the cell, and all cells in the other region will have a value of -D. So one region is doubled, one is negated. 2 arrows of the same color on a cell with value N point to 2 cells N steps away. Negative values go in the opposite direction. 1 for each arrow. And those 2 values follow the corresponding rules. Yellow, the sum of the values is equal to N. In purple, the values are in a 1 to N ratio. Okay, so if this has a value of let's say 2, and that's value, so like, well, okay, if it's in one region, it'll be 1, and in the other, it'll be 2, but point to this and this instead. Okay, if this is in the negated region, then these sum to 2, so these would both have a value of 1. Oh, or one would be doubled, but the other could be negated, so yeah, okay. And not all possible paros are given. Thank you for not making me case check that. All right. They would sum to -2 if it was negated. Okay. Well, okay, this has to be negated. So does this. Because it has to, everything that points off the grid must be negated. AQ, just a question. I'm not going to have to explain the third secret of yin-yang in order to solve this, right? And there's also things like... Oh, okay, I was looking at this. Good, good. I was looking at this because if this is negated, this arrow points this way. But if it's not negated, this arrow points this way. So this can have a max value of 2 or minus 2. So I think this is only ever 1, 2. Can I do that anywhere else? Oh, here. Oh, in fact, this doesn't matter. Okay, so either these sum to minus 1 or 1, or these sum to 2 or minus 2. This is a max of 4. Oh, this is a max of 3. So is this. Oh. Oh, this is just minus 1. Because this is pointing at this. This is also 1, 2, 3. Okay, so these sum to negative 1. They must have different regions. And the positive must be double the negative. Oh, no. The negative must be 1 more than double the positive. So whichever digit is in a positive region, I think it can only be 2, 3, or 4, right? With the negative being 5, 7, 9. Ooh. Oh, this is also only 1, 2. Okay, so that makes this a 1, 2, 3. Sure. This is 4, so it is also negative. Okay, so now we get the doubled. Oh, wait, this has to be positive or else it sees off the screen. So does this. Okay, so because on yin yang, you can only change regions twice on the you can only have 1 block of each region on the outside edge of the grid, unless it's toroidal or something. Okay, so this is positive, right? Okay, so this has to be. Oh, this is a 1, 2 pair, so this is 3 or 4, and this is 7 or 9. Oh yeah, this is minus 1. No, this is minus 3. This is minus 3. Yeah. Okay. Oh wait, this is also only 1 or 2. Wait, doesn't this have to be one more than double this to make these sum to -1? So like if this is 3, that has a value of 6, and this is 7. Oh, it's ratio. The values are in a 1-to-n ratio. Never mind. Are in a 1 to -1 ratio. Okay, so this is double this. Yellow is sum, purple is ratio. So this does still have to be fairly low. This does still have to be 3 or 4, but this is 6 or 8, not 7 or 9. Or 7 column 1 can no longer be 2. All right. In fact, if the arrows point in the same direction, this is sum, don't they have to be, doesn't this have to be, doubled, even? Yeah, it's 4, 6, 8. Same thing here, right? Well, this could still technically be 2. Oh yeah, here too. Good spot. Oh, but it can't be 2 exactly, because that would break this. Oh, I should also now if this is negative, it's 1. Oh, but that doesn't work. Oh, no, it could. Right, because these would have to be... No, this would have to be double this. Okay, it does still work for this to be negative. Oh. Same here, right? In fact, this can only be 2 or 4. Or this 2. This is 4, this is 2. Then these sum to -2. That's... okay. Can't be 2. Oh, right, because this can't be 1. Okay, so this is 4. So this is 2, and these sum to -2. Which, given that this cannot be... This has to be positive. So this is even. Oh, this is 6 or 8. Oh, wait. This can't be 8. Because this would have to be 3. Which it can't be. This is 6. So this is 2, and this is 1. Oh, and now this, that's 4. So that's 2, and I know it's -2 because of this. Okay, so these sum to -2. So that forces this to be positive and these to be -3. Huh? Oh dear. How far back? Okay, was this... Well, these are doubled. Green is doubled. Every digit in green is doubled. So these are... Okay, so I was correct up to here. Oh, right. It's the... This is doubled, so this is 4, not 3. That's what tripped me up before. Okay. So this is 4, right, because this has a value of 2. Alright, and now these... Oh no, these have a 1 to -2 ratio. So, either these are the same digit or one is quadruple the other. So these are either the same digit or this... Oh no. Or this is quadruple this. My guess would be they're the same digit. But we shall see. Oh. Right, and this being 1 means that these sum to 2. Wait, what? How can these sum to +2? Oh, right, this being doubled. Right, this is a doubled 5. And now, because you can't have checkerboard on a yin-yang, these must all be green. Okay, so this being green means it is looking at... Oh. Means this is a 1 because it's looking at these specifically. Okay, so that's 2. Okay, now this has to be negative because otherwise that's looking 4, which puts it off the screen. So this is negative. So that means these are in a 1 to -2 ratio. So they have different... polarities. Okay. Wait. Wait, anything green with a paro cannot be too high or it will go off the grid. So these are only from 1, 2, 3, 4, and neither of these can be 2, and this can't be 1. This is 3, and this is 1 or 4. So this is saying that these sum to 6. So this definitely has to be high. Okay, that gets out through there. Oh, wait, and this can't be 4. That puts it off the edge here. This is just 1. So that these, okay, so these, okay. Now no checkerboard, and now green gets out through here. Oh yeah, purple ratio. These are, oh wait. Yeah, I keep forgetting. Okay. These have a 1 to 6 ratio. Okay, so these have the same polarity. But this still cannot be 4. So these have a 1 to 2 ratio. Wait, if these have a 1 to 6 ratio, aren't these just a 1-6 pair? Because nothing else is gonna... Yeah, okay, and that's 6 and that's 1. Okay, that's 8. So that's 4 to, because of this. Okay, now this gets out through here. Oh, that's 2. Okay, so these have a 1 to -2 ratio, so these are the same. These are different. No checkerboard, and now I need to avoid 2x2s. And now I need to avoid checkerboard, and avoid 2x2s, no checkerboard. Wait. Did I do something else wrong? Oh dear, how far back do I have to... I broke something. Okay, I think I was correct up to here. So this is 1. This is 2. Now this can't be... Okay, this does have to be negative. So it's saying these are in a 1 to -2 ratio. Okay. Okay, and I think I was correct. The Yeah, these are... Okay. Well, because it can't be any higher than 4, or it will go off the edge of the grid. And it works on the purple arrows because it makes them have a 1 to 6 ratio. Similarly, this is 1 or 4, and it can't be 4. That forces it off the edge here. Like, anything green with arrows cannot be higher than 4, or else it just... it sees something off the edge of the grid. Purple, the values are in a 1 to n ratio. And this has a value of 6, so these are in a 1 to 6 ratio. And they have to be 1/6, because there's no other... Yeah, so do I. Believe me. Oh. I think I can resolve this, because if this is 2, these can't be in a 1 to -2 ratio. So this must be 3, this must be 2, and now this is red. And now I need to avoid a checkerboard. Now this needs to get out. These are in a 1 to 2 ratio, so this must be 6. And these are in a 1 to -2 ratio. Wait. Oh, this could be 8. Which it has to be, because it can't be 1, 2, or 4. This is 8. Does this make... does it? Well, I know these... Oh, well, this is a 1. So these are in a 1 to -1 ratio, so that is green. These are the same digit. Okay, so these are in wait. Oh, no, it's these. Yes, this is 3. I keep forgetting to reverse... I keep, like, only reversing one of the arrows when I calculate these. Okay, so these have... Oh, wait. This is correct. So these sum to 2. So doesn't this have to be 2? Oh, I could also look at this. Right, this couldn't be 8 anyway. Oh yeah, I see the parallels. Oh yeah, one in column 5. So these are in a 1-to-1 ratio. Doesn't that mean this is also a positive 4? Which makes this negative. Now avoid 2x2, avoid checkerboard. Right, these some. Oh, yes, I did those already. Oh, not 1-to-1, right. Right, but this is positive, and it's either 2 or 8. And it's not 2, so it is 8. And the same thing. Okay. Now, let me just do Sudoku for a bit. Aha. Okay, if this is green, then this is a red 6. If this is red... Wait, no. No. If this is green, these sum to 2. So this is a green... oh. That doesn't work. Right. This can't be green. Because this would have to be... Because these would have to sum to 5, and this would have to be doubled. You can't do that. You can't... Wait. Yeah. Green 8 would work? But this isn't doubled. It's negated, but it's not doubled. So, yeah, I think this is forced to be red. So these sum to -1. Yeah, this is confusing. Oh, 1-1 left. Okay, now if this is red, these are in a 1 to -1 ratio. That doesn't work. So this is green. 2 by 2, no 2 by 2. Oh, also no 2 by 2 here, and no 2 by 2 here. So these are in a 1 to 2 ratio. Wait, this can't be 1, 2, 4, 6, or 8. I think this can only be 3, right? And the fact that both of these are doubled means that these are just yeah. That doesn't actually change the fact that these have to have a 1 to 2 ratio. Column 7 is very restricted. Oh, yes. These sum to... This is 4... Oh, wait. No, it sums these. Right, so this has to be one more than double this. Oh, wait, this is... Isn't this 4... The minimum this can be is 4... So this has to be, so it has to be 4 with this is 9. Okay. Okay, now Sudoku for a bit. There's 2. Alright, oh. Well, this has to be negated now, because it can't be a 1. In fact, this always has to be negated, because otherwise it would be pointing off the grid. Similarly, this has to be... Okay. Now, green gets out through here. Oh, green also gets out through here. What's left in this row? 3, 5, and 7. Now 3... Oh, that's tempting. What about 5? Ooh, that's not gonna work. This can't be a... Oh. Oh, no, because this would have to be odd. Because this has to be even... Yeah, okay, so 5 doesn't work, and 7... Oh, 7's off the grid, so it is just 3. Okay, so green gets out through there. Now no 2 by 2. Okay, so this is a 5-7 pair. I don't think that's resolved yet. Oh, Oh. Oh, no, it's this. Right, yes. Okay, that's done. Let's see. What isn't done yet? That's done. Oh, this. So these digits are either in a 1-to-1 ratio or they are... That's still pretty... Okay, what can I do with this? Or, wait, this. It's only 5, 7, 9. Can't be 9. If it's 5... those are not in a 1 to 5 ratio. Or a 1 to minus 5 ratio. Wait, what? How does... oh, no, they're not checking that. It's this. Okay, but there's no way to have these in a 1 to minus 5 ratio. This is 7. Oh, no. It's this that's 7. This is 7. I put that in the wrong place. So it has a value of 14, and now it's... okay. These are 5, 6, 8. Now I can do something similar here, right? 5 and this. Ooh, I could make this a 5. What about these? Ah, those have the same polarity. No way to make that a 1 to minus 8 ratio. That is 5. Oh, hey, Abyss. How are you doing? This is... okay. Right. Wait. Oh yeah, I did that. Okay. Now, what's... okay. 3, 5, and 9. It's not 5. This is not 9. This is 3. That's 6. Okay, that's 9. That's negative 9. It probably does, but I think it could also mean that, like, this is quadruple this. Or... wait. Oh, except this can't be quadruple this, because I've used up 1 and 2. Okay, so yes, these are the same digit. Okay, so... it's not 5. Okay, this is only oh, it's only 7, right? Oh, this being... oh, this is 4. Right, so this is 7. Right, thank you. Okay, okay, this gets out through here. Oh, and these connect through here. Okay, we're done with the shading. Right, and now these are always the same digit, and they are, they each see everything except... oh, they could still be 9. Oh no, this sees 9 here, right, so these have to be 7. Okay, now 7 in this box only goes here. I think all the clues are done. I think from here it should just be Sudoku. Oh, wait, no, not. Okay, 8 in this box. There are... Okay. This is 5, 8. One of those is 6. Oh, right, this. Right, this is 5. Oh, which I... Right, yes, which I forgot to fill in before. All right. 4, 6, and 9. Oh, well, 4 goes here. So this is a 6, 9 pair. Nice. Huh? Wait. Oh, these sum to... Right. I keep forgetting which arrows are which. All right. 6 in row 1. Ah, yes. This is 5 and 9. That's 5. That is 9. That is 6. 7, 8, 9. That's 9. That's 8. That's 7. There's also 5, 8, 9. That's 9. That is 5, 8. Okay. 7 and 9. 9, 7. That's 4. 8. 3 and 9. I don't think that's resolved quite yet. Yeah. Alright. Oh. That's 5. That's 9. That is 3, which resolves this. That is... oh. 9. 5 and 6. Okay. Whew. Okay. Only 45 minutes. Dang, that was a breeze. No, that was really cool. I might actually... Oh. Thank you for the crab rave. Alright. Thank you for the GGs. Alright, here's one Marty sent in. Oh, I should ping Marty real quick. This is a really interesting idea. So... Normal Sudoku rules apply, so every row, column, and 3x3 box, I gotta put the digits 1 to 9 once each. No two digits anywhere on a yellow stick may be the same or consecutive. A stick always has a lower total, the sum of its digits, than any stick which lies on top of it. Hey, Marty. Yeah, I wonder, would dark mode... Oh, much better. Okay, yeah, I think dark mode might be optimal for this puzzle. It's weird how Sudoku Pad determines when to flip the colors of something in dark mode and when it doesn't. Ah well. Okay, so what that means is that these are sort of woven. Okay, this has a lower sum than any of these. This is higher than this. So this has the lowest sum in the box. This has the highest sum in the box. Now, what is the minimum? The minimum I can make a Nabner is 135. And the maximum I can make it is 579, but I can't have both of those in the same box. So I could go anywhere from 9 to 21. Thing is, though, I can't have both 9 and 21 in the same box. Well, maybe there's something... Oh. Oh, okay. I missed that some of these were... I missed that some of these were only 2... Oh, this one's 4. But it's not on top of anything. Maybe this is just here to disambiguate a deadly pattern at the end. Well, let me look at this 2. This 2 is on top of this 3. This has a minimum of 9. This has a maximum of 16. Oh, wait. 10. This has a minimum of 12. I only have 1 degree of freedom on this thing, because this is higher than this is higher than that, this is higher. And I don't... Can this even be 10? Because, like, if this is 9, which is the absolute minimum, that's 1, 3, 5. That only leaves 2, 4, 6 for this, so this would have to be at least 12. So, yeah, I think this has to be 11, 12, 13, 14, 15, 16. So this is 7, 9. This is 6 or 8, because this is 15. This is 14. Okay, so this is 6 or 8. And this is 13. Now, how do I make these... How do I make this even sum to 11? Wait, this needs a... Wait, how does this... Oh, they can both have a 1 on them. Wait, so if one of them... Wait. Oh, is this 1, 3, 5... I think this is 1. This has to be 1. No, this is 3, 5. But the pencil marks don't show up very well in dark mode. With this being 4, 6, I think that's forced. Okay, so this is 12. These either sum to 8 or 6. And this is 13. If this is 8, these sum to 5, so they'd have to be 1, 4. If this is 6, these sum to 7, so they'd have to be 2, 5. Huh, that's... this is not 1, so this is not 4. Oh wait, the 6-8 pair looks up, makes that 4, 6. Missing anything else in that? Oh, 7 and 9 in this box. They can only go here. Making this 2 and 8. That rules 2 out of here, which rules, I think, 5 out of here. Depending on... Yeah, because these sum to 6 or 5. Wait, no, they sum to 7 or 5. So it's 2, 5 or 1, 4. Oh, DM it to me on Discord. Oh, that's a bit better to see. Let's see, where was I? 416. 79. 35. 28. Oh, yes. This cannot be 8. And in fact, this has to be 9 specifically to make that... now this cannot be... Well, oh no, I can't put 7 or 9 here anyway. But these have to be pretty high. Especially because this can't be... Oh, does this have to be a 6-9 pair? Yeah, because this can't be 7 or 9. And if I make this an 8... Yeah, because these have to be higher than this. Yeah, this is a 6-9 pair. Nice. And now it just doesn't matter what I put in here. Well, it has to be from 1, 2, 3, 4, but it can be anything with those constraints. All right. This is 12, so they, so these sum to 8. Now, does 3, 5 work? Yeah, what about 2, 6? No, that breaks this thing. Actually, I'm not entirely sure about these pencil marks. Well, no, because I think I proved those. Fair enough. 2, 6 doesn't work. Oh, but 3, 5 doesn't work because those are both next to 4. So it's 2, 6, which breaks this, or 1, 7. Oh, so it's only 1, 7. Okay, so this is 2, so this is 5. Wait. No, I was... Mistake. Okay, yeah, I don't trust these pencil marks. Two, 6 or 1, 7. This is not... Okay, now, if this is 6, these sum to 7, it's not 1, 6 or 3, 4, so it would be 2, 5, one of those is next to 6. Okay, maybe this is just always 8. And these sum to 5, which would be 1, 4. Oh, yeah. Resolved by that. Okay. So what's left in this? 3 and 5. So I know that there's no 4 here. So 4 in this column only goes down here. Ah, that's going to... put some pressure on here. Oh, 7 in this box. 3, 5, and 9. Okay, that's a 3, 5, 9 triple. 1 and 2 down here. This is 3, 5, 8. There's an 8 on here. Probably this one. Well, we'll see. So I can't put 3 or 5 on here. So there's a 1 or a 2 on here with 2 of 6, 7, 8, 9. And there's a 3, 5 on here with the other 2 of 6, 7, 8, 9. So there's a 1 or 2 on here with either a 6, 8 or a 7, 9. And there's a 3, 5 on here also with a 6, 8 or a 7, 9. Now if it's a 5, it's 7, 9. But if it's a 3, it could still be 6, 8 or 7, 9. Oh, I should make the rules a bit bigger on this one too. Okay, one of these is a 3, 5 pair. And that will roll 2, 4, and 6 out of its counterpart up here. Oh, and it sees an 8, so it'll be 1, 7, 9. 7 specifically. So there's a 1 or 7 here. Now if this is 8, no, if this is 8, this is 1, 2, 1. Okay. Oh, maybe I should think about this. No 6 or 9. It's also higher than this, so it can't just be 1, 3, 5. So there must be a 7 or 8 on here. Also this to be considered. This can't have 6 or 8 on it, and it also can't have both 3 and 5. Oh. These, okay. The fact that this is higher than this, so this is greater than the sum of these two. And this is greater than the sum of these two. Wait, no. Yeah, this is greater than the sum of these two. So this cannot be 1 or 2. This can't be 2. Alright, where is 2? Okay, what is... oh. Yeah, because if it has a 1, the max it can be is 16. That's... yeah, that's too big a differential. Because, like, this can't tie with any of these. Hey, Coffin Ball. Alright, so there is a 1 down here. So there is... oh! I mean, Calvin and Hobbes is basically the most popular comic strip of all time, so it wouldn't surprise me if it was taken. Oh, there's a 9 up here. Probably here. Oh, in fact, it has to be. Yes, this has to be 9. Because otherwise, this has to be greater than 9. There's 2 with... oh, right. This doesn't have to be equal or greater. It has to be greater. Summed to less than 9. So there can't be an 8 on either of these. So 8 in this box only has a few places. If there is a 7, it goes here. With a 1. That's fine. If this is 4, this is 1, 2. If this is 5, this is 1, 2, or 1, 3. this is 8, this can be any 2 digits that sum to 7 or less. Alright. Oh yes, the Nabner kicks out 8. Oh, so it's not a 4 because these can't be 1. Okay, so this is 5, and these are 1, 3. Okay, 5, 8. So that's 3, that's 5. Ah, that's 8, that's 5. Okay, this is 1 or 7. That's the only thing left that it doesn't either get ruled out by its Nabner or C by Sudoku. Meanwhile, this is 1, 2, or 3. Alright. Okay. 5 in this row only goes here. Oh. Right, this is 5, 7, 9. Because the other of 1 and 2 has to go on here with the 4 and a 6, 8. So this is 1, 2, 6, 8. That's not 6. Oh yeah, the line must be higher. Right. Oh, and in fact... yeah, this is 1, by that logic. Okay, so this is 2, 6, 8. Five in this box only goes here. Now this line's on top, so this must be bigger than the sum of these. Of course, this is just 1, 2, 3, 4. Oh, that's not 1. This being a 3 doesn't work. Oh, yes, 4 also doesn't. Oh, now 2 doesn't work. This is 3, 1. Ah, alright. 4, and that is 9. This is 3, 7, 8. And wait, no, not 3, 7, 8. 3, 6, 8. And 3 does not go on either of those Nabners, so it goes there. Okay. Now these sum to less than 9, and they can't have 4, 5, or 6. So it's either 1, 7 Or 1, 3? But it can't be 1, 3. I think this does have to be 7, 1, doesn't it? Because nothing else works. Okay, so that's not 1, so that is 1. Okay, that makes sense with this line being the only one that's under this. What's left? 2, 6, 8, 9. Oh, what's left in this? Oh, this is 2 or 4. And this is 3 or 8, resolved by that. That's not 8. 2, 4, 6, 7. Oh, this is 6 or 7. So this isn't 6 or 7. This is 2 or 4, makes a 2-4 pair, makes that 6, makes that 7. Oh, 9 and 8 in column 6. Oh, yes, I should probably look for... Right, one of them has to go down here. Right. Oh. Oh, I could have got this that way. Okay, neat. So, what does that leave on here? 2, 6, and 9. That's not 2, that's not 6. I'm guessing that is 2. Oh, right, this can't have a... Or does it? Wait. 3, 5, and 8? Oh, that's 3. Well, that's not 2. Oh, that's 5, that's 8. Okay, so that's it. That is 9, that's 2, that's 6. Okay, I wound up not actually using this hatchwork arrangement thing that much, but it was still a really cool effect that you were able to arrange these that way. Alright. 3, 5, 7. Oh, that's 5, 7. Okay, so we got a 5, 7 pair in the column. 2, 4, 6, 8. That is... waffle. Yes, waffle also works. Oh, that's 6. Okay, oh, so that's 8. And we're left with a 2, 4 pair in the column. Okay. Oh, but this can't be... This is 3, 5, 7, and this 6 rules 5 and 7 out of there, so that is 3. 1 and... Oh, 6. Oh. Yeah. Yeah, I've been there. 5, 7. Oh. Right, these have to... This has to be 5, 7 for that to work. Okay, so that's not 5, and that's not 7. Okay. Oh, but this is 7 and this is 5, which is going to resolve these. 2, 4, 8. Oh, and it's this, right? Right. 9. Okay. Oh, did you omit a space after the period? It might have parsed that as a link. Alright, thank you for the GGs. next up is this, and then I should probably have time for Dorliers. Yeah, the auto mod is a bit finicky about that. Alright, so here is Chinstraps and Sujoiku's latest collab, or I think it's latest, you said it was latest. Alright, and Chinstrap is here. Yeah, this one was neat, by the way. This little ladder thing over here was really cool. Normal Sudoku rules apply, so every row, column, and box. Very understandable. Gotta put the digits 1 to 9 once each. Index sum lines. The latest for now, yes. Dots separate turquoise lines into segments which are enumerated with white labels in the center of the line. For each line, the sums of these segments must form a valid index line, i.e. the sum of the nth segment along the line, starting from the segment with the diamond, indicates the position along the line where a sum of n appears. For example, if the third segment sums to 6, the sixth segment must sum to 3. Oh, wow, that is, okay. This is 6, this is 3, okay. 1 and 2 can only go in single cell regions, so in fact, okay, this must be at least 6. Oh, and it can't be exactly 6 because that would rule 2 out of here. So these sum to 8 or 10, and there is a 2 in here. There's 8 along here. Yes, hyper index lines. Okay, so what do I... So there is a I say about this line? Trouble is, these... Oh, no, this can't index the 2. Because then this would have to be 1. Oh, and it can't index the 3 either. So these sum to at least 4. Now 2 could index itself. I guess this is 2, 4, 5, 6, 7. There are 2 columns. 7 is 7 or 9. Yes, it is worth. Might be worth that, yes. Ah, you were close. Close. Where is... Okay, I should think about 1s and 2s on here. Here, okay. These sum to 4, 7, 8, or 9. So there's a 1 in here somewhere. Ah, true. True. So in fact, each of them has to be at least 5. So the 1s on this line are in here. The 2s are up here. Can I do that anywhere else? These sum to at least 10. Well, that's a little less restrictive. And 7 also has to be up here. Oh, but it could index itself with a 1, 2, 4 here. Wait, no. No, this can't have a 2 on it, so 7 can't index itself. And it can't index 6 either. Okay, so there's a 7 up here. Now, maybe one of these is a 7, but... without using a 2. Or this is 7. That would be a bit easier. So where is... oh. Now, if this is 1, these sum to 5, so this is here, and these sum to 10. Actually, this may do more that... these sum to 5, 6, 8, or 9. 1 or 2 has to appear in the 10 segment. You mean this 10 segment? Oh, right. Yeah, this is 1 or 2. Okay. And this is 8, 9, 10. So 8, 9, 10 have the 2 and 7 in it. Oh, this is hard to notate. Oh, but wait. If this is 1, this has to have a 2 in it, otherwise it's going to be too high. So this cannot be 1. So 1 is only 5, 8, 9, or 10. Oh no, 5, 8, or 10. So there's a 1 here. But since there's no 2, there must be a 1 here. Oh, there must be a 1 or a 2 on here. Right, okay, so this is 2. And this isn't 1. So this is 1. So it is, in fact, they sum to exactly 15. Okay, so 5 and 10. Okay, so just you sum to 6, 7, 8, 9. Now this could be 1, 3, 4 or 1, 3, 5, but there's always a 3 up here. Oh, yeah. So that's 4. And this is a 1, 3 pair. So that's 7. Now 7 and 8 index each other, so this can only be 6 or 9. And it can't be 6 because this isn't 3. So this is 9, and this is 1, 2. Oh. 4 and 6 are left over, but they can't index each other because of this 4, so they have to index themselves. Okay, so now 4 is not 7, 8, 9. Oh, this isn't. There's a 1 down here. These sum to 7, 8, or 9 without using a 1 or a 2. Oh, and they can't be a 3, 4 pair, so it can't be, because this can't be either of those, so it can't be 7 either. So it's either 3, 5, 3, 6, or 4, 5. Oh, 4 looks down and resolves this, which looks up and resolves these. these are 7 and 8. Are those resolved by... Not yet. One on here somewhere. Oh. There's a 1 down here, but it can't be here. Okay, so there is a 1 on here. Obviously, it doesn't go with a 2 for any number of reasons. And it also doesn't go with a 3, because that's not 2. Oh. It must go up here specifically, because these are multi-cell... Oh, this is a 1-2 pair. So this is 1-7 or 1-8. Interesting, that doesn't quite resolve this. Okay. So this is... Oh, I haven't looked at this in a while. None of these are one. Okay, this isn't one, so these don't sum to 7. There's a 1 in one of these. Oh, 1 in this box goes on here. So these sum to 5 or 6. Now, if it's 5, they're a 2-3 pair, because this can't be 1 or 4. If it's 6, this could still be... This is, if it's 6, then this is 1 or 4, and this is 2 or 5. So this is only ever from 2, 3, 5. And this is 1, 2, 3, or 4. Where does... row 5, column 7 can't index and... Oh, row 5, column 7. Right. Okay, so this doesn't index an 8 anymore, so... Ooh. Right. It goes in one of these two. In fact, this can only be from 3, 5, 6. It's 3. This is 7, so this is 1, 8, so this is 2, this is 1. So this would be 3, 5, okay. This is only 3, 4, 5, 7. So that is... 9 in this box only goes here. Why can't pause 7 be 7? Oh. Right, it can. Where does... Here is 4... I guess 9 in this box only goes here. In this box it only goes here. Now the max this can possibly be is 7. And neither of these can be 6, so the 6, these sum to 5, 6, or 7. Oh, yes. So these are only from 2, 3, 4, 5. That's not 4. It is just barely possible for this to be 3, 4, and thus not resolve this. Wait. If this is 1, though, this is 3, 4, 5. Oh, this could be 5, 4. Takes 5 out of row 4, column 7? Oh, you mean row 3, column 7? Yes, it does take 5 out of here. True. Oh. Can't be 6 either. Or 7. Okay, so this is only 3 or 4. So there is a 4 here. Oh, right, if this doesn't have a 1... minimum this can be is for... Yeah, this always has a 1. Okay, so there's no 1 here. Oh, so 1 in this box only goes here. Okay. getting somewhere, because that resolves this, which forces this. Now this doesn't index itself, because it would have to go with 1, 5. Oh, and neither of these can be 6, right. So this is only 5, 6, or 7. So this is 1, 4, or 1, 6. Now, if it's 1, 4, I think that breaks this, right? Because these can't sum to 6 without a 4. So this is 1, 6. Okay, and now this is 2, 3. Okay, so this is just a 3, 4 pair. That gets... Okay, so this is a 3, 4 pair. Oh. Resolves this, which resolves this. Oh, this isn't 6. So one of these, so either this is a 2 or there's a 2 up here, and neither of those can be, this is just a 2. Oh yeah, 5, 9 pair here. Oh yeah, that is neat. You did manage to, you got all the ones on the lines. Now this is 4, 7, and it's resolved by that. This is 5, 8, 9. That's not 8, so that's 5, 9. Aha. So what we're missing in this column is 3 and 6. Don't think that's what... Yeah, these are the same digit. This doesn't see this, at least not directly. I'll forgive you eventually, Rat. Thanks. Oh, but wait. If this isn't 4, I can't put a 4 in this box. Okay, so this is 4, so this is 5, so this is 1, this is 2, so this is a 1, 7 pair, and it's resolved by that. Seven, 8 pair here. Oh. This is a naked single. This is 2. Which which sees that this is, okay, 3, 7, 8 left in the row. Four, 5, 9. Oh. So this is a 4, 5 pair. Six, 8, 9. This is 8, 9. Now this is also 6, 8, or 9. This is 8 or 9. Oh yes, 3 in box 4, and that makes this a 6. Five. Oh, but this can't be a 5 because of this. So 5 in this box only goes down here. So 5 in this column only goes up here. This is 8 or 9, so there's a 7 down here, so there's no 7 here. Oh, this is 6. This is the only place for a 3 in this row. Making this a 6. All right. Let's look more at this. Minimum this can be is 7. This can't be 1, 2, so this has to be 7. So this is 3, 4, resolved by the 3 above it. Ah. One, 2, and 6. That's not 1 and 2, so that is 6. So that's 6. So we got a 4, 5 pair left in this column, and it's resolved by that. Oh, but now this can only index itself. So that's a 4, 5 pair, and it's resolved by this. Yeah, I think that's the entire thing. Okay, from here it's just Sudoku. Oh, 9. 8, 9, and 7. No problem. Thanks for sending it in. Let me know if you upload it. Alright, I think I'll finish up with Dorliers. Alright. This is called the 6th element. See what you did there? The gray line is a palindrome, reads the same in both directions. Adjacent digits along the green line differ by at least 5. Oh, and normal Sudoku rules apply, so every row, column, and box got to put 1 to 9 once each. Digits along an arrow must sum to the digit in that arrow's circle. Digits on a purple line form a set of consecutive integers in some order. Every run of 3 digits on the teal line, oh, that's this one, they all have different remainders when divided by 3. And box borders divide this line into segments that all have the same sum. Okay. That's all the rules. Okay, so these are all the same digit. Now this, minimum I can make 6, 7, 8. So this is 8 or 9. I've only got 1 degree of freedom. And I've got 1 and 2 on here always. So the minimum, along with 1 of 3 or 4, so the minimum I can make this is 3, 5. Oh, so this is 8, 9. Okay, so I got an 8, 9 pair here. Ooh, and if this is 1, 2, 3, this is 4, 5, so these are 9. Okay, so these are always 1. And I think there's always a 5 on here? Because this is 3, 5, or 4, 5. Okay, now, this cannot be 8 or 9, and it also can't be 6, because this can't be 1. So if this is high, it's 7. If it's low, it's 1, 2, 3, or... Could it be 4? I think it could. Oh, yes. Yeah, the Renbon needs 4, 5, and 6. And it's not getting... Oh, in fact, this is 3, 4, 5. This is 1 to 5. Okay, these are only from 6, 7, 8, 9. Oh, so this is high. Okay, this is 2, 3, 4. Oh, okay, and that resolves this, because this is 7, so this is 2. So this isn't 6. Okay, this is 2, 3, or 4. Oh, this isn't 7. Where is... Renbound certainly isn't getting its 5 from here. Okay, now these are the same, and they are from... Okay, so it's not 7. That's all the highs in this column. So where does the Renbon get its 4? Well, it could get it from a few places. Oh. 6 in this column can only go here, so this is not 6. So the minimum digit I can put on this Renbon is 3. Well, I already couldn't put 1 on there. So now it's just, it leaves out 2. Where it gets 5 might be more interesting. Well... Still a lot of... Oh, where? Oh. Oh, wait, this is an 8-9 pair. Duh. Few too many pencil marks for my own good. So these are the same digit. And this sees both of them. So that is 7. And now the Renban needs to get its 6 from down here. Okay, maybe I can do... Let me do the modularity coloring on down here. Ooh! Yeah! No, this sees these. This sees these. Alright, so no red on Renban. That's not 4, that's not 4. Now that gets me a 9 here. 9 over here and down here. If this is... This could still be the 3, 6, 9. If this is 3 and this is 6. Forcing it there. Alright. Oh. Where does 8 go in this box? It can't go here, and it can't go here because it's already on the Renban. So this is 2, 5. Now... Oh, okay. One of these is 3, 6, 9, and if it's either of these, this has to be... There's a 3 here. But there could be another 3 here, or a 6 here. Alright. Where is... Oh. Seven in this box goes up here. There's... Oh. Oh, no. only 2 spots for 6 in this box. If it's here, both of these are 3. Well, the, oh, you mean the avatars? Yeah, the thing about having avatars from a bunch of different artists is they make them in a bunch of different sizes. Well, it's partly that they're different artists, partly that they're from different, oh wait! Oh no, I was misreading that. I thought there was an 8 in this. It's like, what is this? This is either 4, 6, or 7. And this is 3, 4, 7. And this is either 4 or I guess it could still be a 6. And this is 1, 3, or 4, but I know there's a 3 in here. So that is 2. Okay, there's... There's 10. Oh, there's... Oh, I should think about 2 in this box only goes down here. There's 9. Oh. Oh, right. Since there's no 9 on here, we know, in fact, that this is 3, 4, 5, 6. Or 4, 7, not 5. Okay, if this is 5, that's 4, so that's 5. Oh, and then there's no 5 in this box. In fact, there's a 5 down here in this box. Up here. What can these actually be? And then there's... Eight in this box can only go in one of these. Two, three, four, five, seven? This digit in this box only goes up here. So there's a 2 up here. I'm not entirely sure. Am I on the right track? Okay. Huh. Or 3 column 9 is 4 or 5. Why can't it be 2? Oh, right, it can't be 5 because it breaks Renbon. Okay. If it's... I think it can also be 7? Or does that break something else? Oh no, that forces the... Right, it can't be 7. Right, because of this. If these are different, this is 4, and this is 5. So this is 4, 3. Oh, but then I can never put a 4 on the Renbon. Oh no, 4 goes here. These are different. This is 4, 5. That's 4. So this is 4, 5, 4. 3, 6 pair down here. 8. Oh yeah. there's 2, 3, 4, 7 in this column goes down here. If these are 2, and these are both 3, oh, then that's 4. So that's 5. Not seeing any reason why that breaks. If this is 4, that's 3, these are Huh. I don't see, I guess if it goes on the Renbon, it must go here. So, like, if this is 3, 4, or 5... Wait. Oh, no, this being 3 would be tricky, but I think doable? So this is 6. Oh, but then this... Okay, yeah, these being 3 breaks this. What about if these are 4? Oh, then these are both 3. 6, 4. Oh, then this becomes 6 and this becomes 3, and that breaks this. I feel there's probably an easier way to spot something that I'm missing. If these are 5, this is 6, this is 5, so this is 2. Oh, that's 3, that's 2.
Come on, Tails.
Oh, then I can't put 5. Oh, right. Right, it can't be 5 because of this. Okay, sorry, brain is a little... So, if these are 2, 3, 1, 2, 3, 4, 5... These are both 4 in that case. Oh, but that breaks these. Okay, I guess these are both 7 then. So that's not 7. Okay, yeah, I mean, I'm probably missing some more obvious way of getting this, but I don't know. I think my brain is a little too fried at this point to, Is there something I could have done with, like... I think one... One of these must be blue and one must be pink. But that's of limited use until I know what those are. Huh. Oh. All right. Is there some reason why... Wait, is this... Okay, so that's 2. Now these both have to be 1. Okay, so this is not 3. Maybe I should think about it this way, because if this is 3... Oh, that breaks this. So there's no 3 down here. So one of these is 3. So... Oh, and they both see this. Oh, wait. If these are both 4, then this is 4, and now I can't put 4 here, so these are 3. Okay, that was simpler. That is 3. That is 3. That is... Okay, that is 6. 2 column 4. Aha! So we got a 1-9 pair here. 3 bucks, 4. Yes, yes it does. Okay, so that is the 4 on the Renbon. This is 6 because... Oh, 6 in the box. Ah, 3-6 pair. Two, 4, 5. That's 3. There's 3. Okay. That's all the clues. So from here, it's just Sudoku. Rogan? Oh, no. Okay, so I am on the right track. Nah, I'm almost done. I will see this through. 1, 4, 5. That's 1, 5. Two, 8, and 9. Oh, 2. Uh, 1, 4, and 5. Is that... Oh. Four, 5, and 6. Oh, 6. This is 4 or 5. 1, 4, 5, 7. Five, 7. Oh, there's 5. So there's 8, there's 7. Oh, yeah. All right. Okay, 4 in this row goes here, which rules it out of there. So 4 in this box must go up here. Oh, 1, 4, 7. That's it. Aha! Six, 7, 8. Ah. 4, 6, 8. Whew. All right. Alright, is anyone doing puzzles? Nah, just me. I would advise against it. Oh, neat. I will check that out. Alright. I'll lead off next Monday with that one. Okay, Culverit's doing blueprints, so I'll raid them. Alright, I'll be back Monday. It may be a while before I can do more Wednesday game streams, but we'll see how I do. All right. Thanks for joining me. Hope to see you again, and bye.